Hello everybody, my name is Anton Glinkin, I am application engineer and CDT. And today I want to talk about different techniques that exist in Expedition and Paths Professional as well to create net shorting. Net shorting is a thing that is not really commonly used, but it's quite often used when we're talking about ground union, about ref stuff. It can be very tricky sometimes since SES and constraint management in Expedition very often prevent you to do this, and it may be not very intuitive. There are several techniques, legacy net shorting techniques. We will talk about Starpoints, about Tiebars, what is the difference between them, and answer some questions. First, and the oldest one technique is pipe net numbers. Pipe net names, I'm sorry. The easiest thing is to do it in Designer. You have two nets. In our case, in our example, it's ENA and ENB. And we create new net and give it a name. ENA, vertical line, ENB. This will combine them into new net, as you can see it in Navigator. That will be called ENA ENB, and that will allow you to create this type of net shorting. So this is my demo project. I already did something, but for demonstration purposes, let's take any new component, add it here. And for example, I want to net shorten, I don't know, let's say pins 3 and 4. Imagine we have two nets, and for the name, let's say we will name them net A and net B. And I want to combine them in one net. So for this, I can create just a new net. And for its name, I can add something like that. As you noticed in our Navigator, we got a new net named net A, net B. And if we transfer this information into layout, I will show it to you a little bit later, it will be very easy to just connect these two pins with two different nets. Bus rippers. This is another feature that is kind of hidden, not really widely announced that you have this possibility. So I will explain how it's working now. On the screen you see that we have a bus 1 to 8. It means that nets contained in this bus will have names bus 1, bus 2, bus 3, etc. bus 8. If we connect this bus to nets out 1, out, whatever, names is up to you, and rip them, you will get a new window called rip nets. And then you need to manually assign a net from outside of the bus to the net inside the bus. So let me switch to the demo one more time. First, let me create some bus and call it, I don't know, test. How many pins do we have? Around 8, I suppose. Test 1, 2, 8. So it means if we try to rip nets from it, we will get these nets. Test 1, test 2, test 3, and so on. Okay. If we want to combine a bunch of nets, 5, 6, 7, 8. And let's say these nets, we want to rename them. Another cool feature, but most probably you know this, you can bulk name these nets. And let's say we want to name them demo. with delta 1, it means that nets will be named like that. So now if I want to globally combine demo 1 to test 1, demo 2 to test 2, and so on, what we can do, we can just connect it. And you see on the top of that window, we have demo 1 net is being connected to bus, and we need to choose the net from the bus. So demo 1 should be connected to test 1, for example. Demo 2 is being connected to test 2. Test 3, test 4, test 5, test 6, test 7, test 8. Oh, my bad. So now our nets combined using this method. Again, after the packaging, this information will be transferred to the layout, and you will be able to see it. To control this type of net sorting in Designer, we have check called DRC1 to 8, shorted and alias nets. Let me switch back. So if you notice, we have DRC1 to 8 check enabled. So if I run it, I will get this report that's showing all nets shorted with different methods. For example, demo 1, demo 8 that we just created. They are connected. And net A, net B, that was aliased using pipe name, also is reported. And previously created nets are also here. Layout. We have also legacy technique in layout called shorted net. This is one of the oldest in layout, I think, if not the only one that existed before. It's native net sorting, so you need to have via or component, and in its settings, in the very bottom of that dialog window, if you open it and edit the shorted nets using edit button, you will see that window where you can add nets that need to be shorted. You choose these names, you transfer them to the right side included and press OK. Then you hit apply, so the changes will be applied to your path stack. And OK, to implement this to the layout. You can assign multiple nets to the single path stack. You can control which nets should be connected to that path stack on different layers. This gives you much more flexibility. Let me switch to layout, and I will run packager, so we actually can have more space. Sorry for this, my machine is not the most powerful one, and it's also making a recording at the same time. So we got this new IC that we worked with previously. This is our shorted nets. What is this? This is net A, net B, and it's too thick. So let me change it to the 5,000s. Like that. This is what I was talking about. This is net sorting using path stack. In our case, it's via. This is shorted via. And I added two nets, net 2 to layer 2 and net 3 to layer 3. So we connect them. This is the dialog window I was talking about. So for example, if I want to add net, an additional net to layer 2, I can just choose it, choose new net, add it here, OK, apply, OK. And now I can connect ground, but only on net 2. If I try to do that on layer 3, for example, it will not allow me to do that, despite that I have gloss. Okay, one more time, not allowing. So if I switch to layer 2, and that's how you can quickly on the fly create net shortening. However, in this you have limitation. It can be only via or another path, so you're limited. Starpoints. This was introduced in VX 2.5. This is different method. As you can see, it utilizes symbol and footprint. It's used to short multiple nets at one common physical location. It provides you more variability inside this configuration. How it's done? You need to create the specific object, and during layout, each path on the Starpoint cell can be set to different layer using path stack properties Starpoint path settings. And shorts will be created in these Starpoints, and they will not be flagged by online DRC. You can generate allowed net shortening report, and there is a really nice article explaining how to work with Starpoints. So how are you actually creating this? First, you need symbol. Symbol type must be module. You need to add properties forward to PCB equals true, part list exclude equals true. So it means that this object should be included into layout, but it shouldn't be showing in BOM file because this is not a part. For each connection you want to connect to Starpoint, you need to have a pin, and this pin should be bidirectional. For cell, you need to create cell. Package group should be general. Mount type mixed. There are some pin requirements. You need to have only one through-hole pin for the first pin, and all other pins should be SMD pins. They also should be placed on layer 1 at the same location. So for your reference, it would be much easier to use origin of coordinates 0, 0 for all paths. To be able to do that, you need to turn off interactive DRC in cell editor when you place in SMD pins. Let me actually show you the inside of it. For symbol, I don't think it's actually quite interesting because this is just a symbol, but for cell, to be able to move Starpoint, you need to be in part placement mode because this is a part in terms of library objects. All right. So as you can see, we have 4 paths here, 1 through hole, and 3 SMDs. And they are located exactly on top of each other. Okay, let's move it this way. If I move it like that, you actually see that all SMDs are stacked in the same position. This is my origin 0.0, and I just disabled an active place and route DRC to stack them on top of each other. If we take a look at characteristics of that cell, we will see that this is exactly what I showed you previously. General, mount type mixed, number of pins, placed 4 out of 4. So for the part of the Starpoint connection, you need to create part number, part name, and you need to create pin mapping. So pin 1 connected to pad 1, and so on. If you want, I can show you this as well, but this is not something special. You added this symbol to your designer, you packaged it, and only after packaging you will see this component in Component Explorer, so you can place it. That's how it looks like. If I open its properties, This is a part. And if I open path stack properties, you will see that I just combined 4 nets. I shorted 4 nets: normal ground, digital ground, chassis ground, and another ground on different layers using this. If you created this cell correctly, only after that in path stack properties you will see Starpoint path settings. If your coordinates of paths are off, not equal, you will not be able to see it. So you need to check your settings. Tiebars. Tiebars is the latest one. This is the latest option to create net shorting. It was introduced in VX 2.8. It's used to create single layer nets. You can shorten between traces, pins, vias, planes, and conductive shapes. However, you cannot connect two tiebars together, and there are two different methodics, two different subtypes of tiebars. One is schematic driven, second one is layout on the fly. Again, tiebars will not be flagged by online DRC. However, if you run allowed net shorting report, you can see all information about tiebars. There is a nice article MG613543 how to create these tiebars. So for your reference, you can read this article as well. But for first type of tiebar, schematic driven tiebar, we also need symbol. It also should be module. It also should have properties forward to PCB, part list exclude, and all pins should be bidirectional. However, for cell, it's slightly different. Package group should be buried, mount type should be surface, and pins must be SMD path stacks. The process of creation special tiebar trace is a little bit tricky, but I will show it how it's done. Very important thing, SMD paths that you are connecting cannot be larger than tiebar trace width. This is very important. A couple days ago I spent like an hour trying to fix the bug, and apparently it wasn't a bug, it was my acknowledgement about this requirement. If your tiebar trace will be less than SMD path width, you will have critical error related to Intel DLL system. Tiebars of different width require different package cells, and you can create them as an alternate cells in PDB. So this is tiebar I was talking about. Let's create something similar. As usual, let me create tiebar. Let's say 3, 4 point tiebar. Total number of pins, it means I need to have 4. It means I need to have 2 layers. It should be buried and surface. So we got our placed pin window. For this tiebar, I don't know what I want to use, so let me check. I want to have SMD rectangle. SMD square, let's say 1,5 millimeter. So it means I need to have one column, 4 rows, and spacing to the left side. Okay, first pin, let's put it into 0, 0. So now we can just quickly rearrange our paths in which order we want to place them. Let's say we want to make them line. To create Tiebar connection, what you need to do? First, you need to start plowing. F3 by default, but you need to create the thickness that equals to your SMD pad. Our SMD pad is 1.5 millimeter. So I will choose new custom width equals 1.5 millimeter. I'm still in movement, so I didn't click anything. And while in movement, you need to press T button, T, Turkish T, English T. After that, you get the red net connection. This is basically how it's called, hint for you. Select second net. So it's asking which nets we actually want to net shorten. First of them is the net of that path, and the second one, click here. Now we place in Tiebar, as you can see in status on the bottom. So I can create like small Tiebar and then finish it with my normal trace. You need to repeat this process for other SMD paths. So it means start to plow, T, choose the pin, connect, width, T, pin, click, connect. This is Tiebar that you just created. This T button is quite important, but more important is the thickness of the trace. After that, we can save it. After that, as usual, we need to proceed to the part. And again, as a normal part, it should have part number and part name to associate schematic symbol with cell. Then you need to add pin mapping and assign footprint and add this symbol to your designer, run forward annotation, and after that it will appear in the component explorer so you can place it. I think I need to show you some example of Tiebar to ensure that this is just a normal part and there is nothing interesting, to be honest. So as you can see, I have Tiebar. In pin mapping dialog, we have just a symbol, just a cell, and in pin mapping, pin 1 map to pin 1. That's it. There is nothing to do more. This is for your reference. There is also Tiebar that you can create on the fly. This is very similar that what we just made in Cell Editor. You start to trace, you start to plow, then you select first endpoint, press T, activate Tiebar mode, click the second net to attach the net red net line, and finish the connection. That's basically it. You got the easiest, the fastest Tiebar that can exist. However, there is another more fancy stuff to do. It's called Tiebar drawing cell. It's also Tiebar on the fly, but you need to make some preparation to see the effect. First, you need to create Tiebar drawing cell. I will show you how it's done. For this, you need first to go to Library Manager. In Library Manager setup parameter, you need to create new user layer. Let's name it Tiebar user layer. You create new drawing cell. Please note this should be drawing cell, not the normal cell. And inside this cell, in cell editor, you just add two text objects. One should contain this text, first line, second line. Both these texts should be created in Tiebar user layer, and you shouldn't add anything to that drawing cell. You can modify these lines, just please remember that you need to save net1, net2, layer, and Tiebar number. This is like a cipher password that will be used inside the text. It will be dynamically updated. So it's up to you. It's based on your company requirements for the design. You can modify it on your choice. After that, we saving the drawing cell in cell editor, switching back to our layout, open library services from layout, and import this drawing cell to project library. To be able to more effectively use it, you need to remember several keyings. DTBC cell name, you can choose default Tiebar that will be used in your design. DTBC question mark, it will show you current default Tiebar. DTBC plain removes any designated Tiebar drawing cell. RDTBC resets all design Tiebar drawings. RNTB renumber all existing Tiebars to fill any numbering gaps created during placing, and so on. So what I was talking about. As you can see, I have a couple examples here that I've made during this webinar preparation. Let me delete it and delete this Tiebar. So let's say I want to connect these two pins. So I can just start to plow, press T, choose the second object for net, click one more time, and finalize my layout. Why do you need this drawing cell? For documentation purposes mostly. It's sometimes pretty easy to forget that you connected two nets intentionally. It may be important on the later stage, during the bring up stage, during the debugging. And since this information is located only on the user layer, user draft layer, you can effectively add it to your documentation, to your assembly documentation, up to you. It's just very nice to have this information somewhere inside the project, just in case. All right. There are some limitations, of course. Tiebars package cells are not supported in Flex designs. For Flex designs, you must use layout on the fly. Just layout, T, click, layout. And Starpoints and Tiebars are not supported for circuit move and copy, manage blocks, and physical reuse. This is the only limitations currently existing. And this, for your reference, really good spreadsheet explaining nuances of each method that I just showed, and its limitation and its capabilities. For example, for Tiebar layout on the fly, you need to have drawing cell, but it's optional, just for better usability, let's say. You cannot short more than two nets. You can use shortening only on single layer. It's not merging net names. It's nets shorted through the cell, and it supports reuse of the components. And I think that's all I have for you today. Çok teşekkürler. Kolay gelsin.